Welcome to Linked Data Engineering. This is lecture number 5, Linked Data Mashups and Applications. We have already shown you how to publish linked data and what are the best practices to consider when publishing linked data in general. In this part of the lecture, I will show you how to publish your own linked data. So, as usual, we start with the linked data principles. I can't tell it you too often, so we have to use URIs for names and things, and of course these should be accessible via the web, which means you should use HTTP URIs. And of course you should provide useful information using the W3 standards, RDF or Sparkle. And finally link to other URIs, because only then other people will be able to discover more information about the things you have published. Okay. First of all, if you want to publish data, you have to understand your data. So look at your data that you want to publish. What are the key things present in your data? Is it about people? Is it about places and geographical objects? Is it about books, films, musicians, photographs? Or is it a review website? Are there comments you want to publish? Are there animals? Are there plants? Is it research data? So it depends on what kind of data you want to publish. You have to understand it because you have to make lots of decisions, for example, for vocabulary reuse. How should this data be published depends on what is in your data. So therefore, please look at your data first. So we want to make this on a small example, and I found something quite interesting on the web that you also might use. I have found a dataset with the deaths of characters from the popular TV series Game of Thrones, which is based on a book from George R.R. Martin, A Song of Ice and Fire. This is an interesting dataset. I have found it at kaggle.com. You can look up other datasets also there. This is a website which provides dataset for further analysis. And these are interesting datasets. So for example, for Game of Thrones, there is a dataset with battles, and there is a dataset, of course, with these character deaths. And in this series, lots of characters are doomed to die. And you will see in this dataset, simply look it up via the URL, that there are, for example, character names. So this is about persons. So there are character names. These characters have allegiances to several houses of nobility. Then, of course, each of these persons has a gender. And then there is an information whether they are nobility or not, and in which book they are appearing, and in which book they are dying, and in which year in this, of course, fictive or fictitious time line, when do they die. Okay, and here is this data. I have simply downloaded this data. It's in CSV format, and of course you can use Excel, for example, or you can also use here Google spreadsheets to take a first peek into the data. So what are we seeing here is a simple table. This is CSV data. The table is arranged as relational data. So in a table, we have several rows. And if we look at that, we see that each row stands for a character. We have in the first column the character name. Then we have the allegiance. So for example, Adam Marbrand has the allegiance to House Lannister. And then you see, for example, so if it's available, is there a death year, the book of death, in which book they die, a death chapter, in which chapter of that book they are dying, and there is also a book intro chapter, when have these characters been introduced, then the gender information, is it male or female, nobility information, is it noble or not, and then of course in which book this character appears. And there are lots of characters, I can tell you. So just have a look at this data, and then of course we are trying to make sense of this data. So what we see in this data, first, it's about persons, and of course the name of the person here works as a kind of key in that table. So we can use all this data, which of course reflects information or properties of this character. You see, if we look at the table, the rows are usually information about one entity here. So the first one about Adam Marbrand, for example. And if you look at the columns, if you look at the column labels, these somehow stand for the properties. And of course then the value of a single cell would be the property value for that character. Quite easy, isn't it? So if we do this simple kind of interpretation, for example here with one of the characters of Game of Thrones, with this, which is Robert Baratheon, here we see how we could arrange this. So I have simply here now put Robert Baratheon as the subject in the center, and then I made a graph from it, and I simply put all the property values that I have found as literals out there, and I have simply used here the names of the columns as property names. And we see here he has gender 1, nobility 1, appears in book 1, which means yes, he appears there, and in the other books you see here he doesn't appear. The allegiance, of course, is to House Baratheon, and the death year is given, the book of death, and so on and so on. You could publish it exactly in that way. So the problem here is if you are only using your own vocabulary, so if we would simply use this as the URI or as the name of the properties we are using and putting this in some own namespace, other people probably won't be able to make any use out of that. So therefore, we have to think about what kind of vocabularies we should use to exactly represent this data in a way that other people also can make sense of it. Okay. First thing, I have somehow substituted this appears in book 1, appears in book 2, and so on, via the information that the character appears in a specific book of that book series, which are 5 and soon 6 books. And I have put here the books as I have found them on DBpedia. So for example, appears in book 1 means this character appears in the first book of the series, which has the name A Game of Thrones. And the book of death of this character happens to be also the first book, which is then also A Game of Thrones. And I took this from DBpedia, which again puts already a little sense into the data. Of course, appears in and appears not in is not an already known property. Probably we have to think about something else for that. Another thing, noble. So nobility also was 0 or 1, and you can substitute this again with something from DBpedia. I have taken here the DBpedia ontology, which provides a class which is DBO noble, and there, of course, there are people listed who are member of nobility. And then I can say simply Robert Baratheon is of RDF type DBO noble. And then, of course, somebody could make sense of this information because it's from DBpedia, it's from the DBpedia ontology, and other people are using it. So the principle that we follow here is we simply reuse already existing vocabularies and we don't reinvent, only if it's necessary. And of course we can mix vocabularies liberally as we want to. What would be potential ontologies or vocabularies to use for our dataset? We are dealing with persons, so therefore, of course, we know already the FOV, friend of a friend vocabulary, which of course gives or encodes information about persons. This would be a good choice to use. On the other hand, of course, we can also make use of the DBpedia ontology, since there is lots of data about persons, about books and stuff like that, that we can use. And we should also take in mind not everything is available in DBpedia. There are other general encyclopedias, like for example Wikidata. In Wikidata you could get information about gender of a person and whether it's male or female. This is not available in DBpedia ontology right now. Possibly it's there in the next release, we don't know, but it's already there in Wikidata, so therefore we could use it. So let's have a look on what this means for our small data set. Okay, the appears in, I have not found this property in DBpedia ontology, but I have found it in Wikidata. And in Wikidata, the names of the properties and also of the entities that are available there are not self-speaking names. There are simply encoded properties with a P and then a number, entities with Q and then a number. And therefore, the property appears in or is character of something is Wikidata P1441. But if you look it up in Wikidata, you can make sense of this property and understand what is written there. Let's have a look at some more. So this would be the gender information. I also take this information from Wikidata. You can look it up in Wikidata. If you look at Wikidata, property number 21, it's the gender property, and the other one, Q65811097, this stands for male, for a male individual. Next one, I have found something like a last appearance. So if a character has a last appearance in some book, in some movie, you can use exactly this property from the DBpedia ontology, and then you can encode that Robert Baratheon has his last appearance in the first book in A Game of Thrones. And you will also find death date, you will know that already. So then the death date of Robert Baratheon is here 298, and I have converted this to a typed literal, and I have made a year out of that. And then of course we are using FOF name and say the name of Robert Baratheon is Robert Baratheon, written here in English. What else can we do? If we keep Robert Baratheon in our own domain as an entity which is represented in our own domain, we can at least make a link to an existing entity, which means then we make a same as link to Robert Baratheon in DBpedia. So we have the DBpedia resource Robert Baratheon, which is of type fictional character. You see more information available there about Robert Baratheon, which is not in our dataset. But nevertheless, we can deduce that then also, because of the same as link, Robert Baratheon must also be of type fictional character, which gives again much information about what is there, because fictional character is also part of a huge class hierarchy in the DBpedia ontology, which in the end means this is some kind of person. It's a fictional person in that sense. Then I decided to use also DBO allegiance. It's also a nice property available in the DBpedia ontology, and I have converted House Baratheon, which was previously a literal. I have translated this or converted this here to another entity. And then of course I could say that this entity is exactly the same as in Wikidata, this entity Q2304848. This entity is now not available in DBpedia, therefore I have chosen it from Wikidata. And you see here I can reuse lots of information from other vocabularies. Of course, there are some things which I did not find somewhere else. For example, book intro chapter and death chapter. I did not find this somewhere, so therefore I decided to do this in my own, or put this in my own namespace, which then would mean Robert Baratheon, the gray one here, the House Baratheon, gray one here, and also the two properties, book intro chapter and death chapter, would be part of my own vocabulary that I somehow complement and also provide for this dataset. Okay, so how then should I go on and choose the URIs for my own namespace, for my own data? First rule, keep out of other people's namespaces. So DBpedia namespace is already used, so it does not make sense simply to add something behind here, Neil Armstrong, for example, and to add /mything for something which is already available in another namespace. So this only makes things much more complicated. Don't do things like this. Another thing would mean abstract away from your implementation details. So you should favor something like here, dbpedia.org/resource/Berlin. Instead of using this long URI, which here gives you again a port number and some CGI resource PHP script which receives a parameter and stuff like that. So this should also not be a URI that you choose for your vocabulary. And if you are talking about yourself, or so the concept or information about the concept, you should of course use this hash or slash notation that we have already spoken of right in the beginning of the course. So what kind of patterns should I use? In DBpedia, this is the upper half of the slide, for example, the things, the entities are in a namespace, which is dbpedia.org/resource, and then you go to the thing. And then you have this content negotiation, and if you want to go to the HTML page, you refer to a directory which is called page. And if you want to go to the RDF data, this then switches or transfers the link to resource which is in the subspace data. And of course, you could use the same pattern also for your own namespace. So for example, here you could use it in mydomain.org. You could here use thing, RDF, and HTML, and then put everything that you want to name behind that. Or you could, for example, use mydomain.org/ the thing you are referring to, and then you use an extension, for example, thing.rdf for the RDF data and thing.html for the HTML data. You can be creative there. Of course, then also you should provide some patterns for content negotiation, and then simply to choose the right thing that, of course, the user wants to access with his HTTP request. Another thing which is often used, structure your namespace. So for example, if you are talking about persons and you also have other things, you might of course here introduce a substructure where you, for example, put all the person entities in your namespace. And this of course would be a subdirectory called persons. Or we also have a subdirectory called families for the house Targaryen or the house Lannister. Okay. So converting your data to RDF usually is not so problematic. So we see here the most simple and the most common form. We have data in form of a database, and we do a database export, which then could be a CSV file. So you have a comma-separated value file, and this means we convert our relational database to RDF. We have already talked about that. So the rows usually denote the facts about a common subject, and this subject is denoted by the primary key of that table. So it's the column that contains the primary key. In our case, it was the name of the person. Then usually the columns that you have, they denote the properties, and you see the property name in the column header. And then the symbol fields are the property values. And this is the simple interpretation how to convert a table into RDF. And then you go on, for example, you substitute the field values with suitable URIs. Either you take them from another existing data set, or of course you put them in your own data set. Like here, for example, you find a field which is named Jon Snow, and then you simply replace it with http://mydomain.org/person/Jon_Snow. Which then would be a URI for exactly that entity. Or you interpret the field as a literal or a typed literal. Here 299 I interpreted as a year 299. So this then is a typed literal. Yeah, and you see here, if you look again at the data that we wanted to transfer. So for example, the first column is the key column, which contains the name, and I decide to make a URI out of that. So this then would be my subject, and all the others then would be interesting property values that I have to connect, and I simply convert it in the way we have just referred to. And while doing this, we reuse existing vocabularies whenever possible. So for example, for Jon Snow, I use here several vocabularies. So I can use FOV, I can use Wikidata, RDF, RDFS, and DBO. And of course, my own namespace, which is the first prefix I define here. And then I simply gather the facts that are available. For example, I can say Jon Snow has a label referring to it, an RDFS label Jon Snow, also a FOV name with the same name. I can say it's of type fictional character. I can say the allegiance of Jon Snow is the Night's Watch, and I can say the death chapter is 47, and the last one here again refers to the gender of Jon Snow, which is male, and this is taken from Wikidata. Here the values in bold script, they are in my own domain, so this belongs to my own vocabulary, to my own data set. And this would be a way to convert exactly this table. Now you have all means to do this conversion by your own, and if you want to, simply convert the entire table and publish it on the web as linked data, as we have seen. And of course, you should make links to other data sets. We have seen this, and you can do this, of course, for example, with OWL same as, but also with other vocabularies, like, for example, the SCOS vocabulary. And then you can connect your domain, mydomain.org, I have called it, with Wikidata and DBpedia as we have done it, but you can also choose different already existing data. For example, data which refers to movies, which refers to actors, like the linked movie database, for example. So you are free to connect anything which seems to be appropriate to that. And this is how you simply publish your own data on the web. Of course, you should think then also on setting up your own infrastructure. You should provide an RDF store and some kind of web server which does the content negotiation, so that with your HTTP GET request, then content negotiation is carried out either way you want to see a human-readable HTML file or the machine-readable RDF. And then you're ready, and your dataset is part of the web of data. So that was it. This is how to publish linked data. In the next part of the lecture, we want to dive deeper into linked data programming, writing your own applications with linked data.